From the Library of Congress in Washington, D.C.
We're going to start things out with Structured Data Storytime from Rachel Shorey, who is a software engineer in the Interactive News Department at the New York Times. She works primarily on large data collection projects in the newsroom. Take it away, Rachel.
Hi, my name is Rachel Shorey. I'm a software engineer at the New York Times on the Interactive News team. I'm going to tell you some stories. First, I want to talk a little bit about the Interactive News team at the Times. We work on a variety of projects, but we often end up being pulled in when reporters get stuck trying to deal with a data problem or get a full understanding of a data collection. We pitch in when data is hard to get or when there's just too much of it for a reporter to deal with. We pitch in when the form is unusable. And we pitch in when it's not even totally clear where the data set is. So I'm here to tell you a little bit about the story, the data story behind the story that you might see in the New York Times. This is the kind of thing that happens when you get programmers in the newsroom collaborating with reporters. First, I want to tell you a little bit more about how the Interactive News team, or my part of the Interactive News team, works and collaborates. One data set that we've done a lot of work on is election data. And when I tell people that, they say, that's so great. I love the New York Times election coverage. I especially love those maps and graphics. And I say, great, me too. Those are somebody else. It is a great data project. And we do, in some ways, contribute to it. If you imagine those as like a really nice restaurant kitchen or something like that, with like the fancy dishwasher and the fancy sink with the like hose that you can wiggle around, and maybe one of those refrigerators that has the cold water pump all hooked into the water system, they're like, that's great, you're like the plumbing. And I'm like, well, really, we're more like the thing that connects the whole restaurant to the city's water main. We're really far back there. But if it breaks, you really know about it because there's water everywhere. So that's how I think of some of the work we do on the interactive team. But I think the best way to talk about that is to show it through the way that these stories come together. So here's a story. Once upon a time, there was a troublesome web interface. Here's an example of a web interface that caused one of our reporters some trouble. This is the Bureau of Prisons, and they make a website that makes it easy to find an inmate who is in the federal system. Unfortunately, if you want to find an inmate, or well, I would say fortunately, actually, because there's some privacy protection in here. You can't just type in an age and find any inmate of that age. You have to know the person's name. You have to know some information about them. So in order to do this, you have to know that information. And here's an example of how a search might work. This is an inmate you may have heard of. As I said, to search for a person, you have to enter their first and last name, and it won't work unless those names are correct. And if you want to find a lot of people, you're going to have to enter them one at a time. A reporter came to me with a large number of individuals that she wanted to look up. She wanted to look them up because they were convicted of terrorism in US courts, and she wanted to know where they were located. This was a big deal not too long ago because there was a lot of question about whether people in Guantanamo could be tried or held in the United States, or in the continental United States. So she wasn't quite sure what to do. She had all of these people she wanted to look up. There were a lot of them, and it was going to take a long time. And to make matters worse, many of them had 3 or 4 names, and it wasn't quite clear how they divided into first, middle, and last name. So thankfully, she had the good sense to apply a little software nerdery to this problem, which she did. Basically by turning around. I happened to sit right behind this person, so it was a very easy request. She said, Rachel, I need some help. How are we going to get this data out of this website? I know the data's there. I just need to get it. Thankfully, the back end of that website looks like this. Anybody who has a little bit of familiarity poking around the back ends of websites will probably have a warm feeling in their heart about how nice and easy it is for a software developer to pull down data like this, to process it, and turn it into usable records that the reporter can use. I started working on this. She returned to calling government offices and asking them for comment on things. Everyone worked on what they did best. We ended up turning this into a story that also included this map. We found out where the people who were convicted of terrorism in United States courts are being held, indeed in the United States, and wrote an accompanying story about it. So using the information that we we're able to gather as a collaboration between a reporter and somebody, a software engineer who works on data things, we were able to tell a story that countered the narrative that was generally being told at the time. I have another example. I really like this one. Another example. I really like this one. A doctor testified in court, but his name was redacted. Some of his biographical details were available, though, including his date of birth and his date and place of certification. Sorry, not date of birth. And some additional biographical information. And a reporter discovered that there's this search functionality available for the American Board of Psychiatry and Neurology that lets you determine who was certified or recertified at in a certain place and at a certain time. He knew, as I said, the month and year of the certification of this individual, but nothing else. If you look at this web interface, you might note that date of certification is not an option. What he really wanted was to search by date. So he's stuck at this point. Thankfully, he knew the phone number of some local software nerds. This actually did happen late at night, so he did call someone. This call did not go to me. It went to my colleague, Jeremy Bowers, who was supposed to be here today, but unfortunately could not join us. So what Jeremy was able to do is pull out all of the data from the database and then do the search and then give it to the reporter in this format where he could search and sort by date. There were about 900 people who matched the date that the reporter was interested in. What he did at that point, the reporter, is he started Googling. He actually Googled 88 of these people, and then he found somebody who, based on other information that was available online, matched other biographical information in the testimony that he had read. So, yes. After doing this Googling, the reporting team sent somebody to the house of this doctor, knocked on his door, and they asked for an interview, and they got an hour on the record with him. This is really a story that could not have come about without true reporter-programmer collaboration. We didn't have the idea to go and pull data off that website, and we didn't have the ability to go and knock on the door and ask. I'm a software engineer. Can you imagine me knocking on your door? I'd probably be like, hi, I'm with the New York Times, and I'd like to ask you some questions, and it probably wouldn't have gone well. So it was really a great collaboration. Here's the story that resulted. It was actually part of a 5-part series about medical and psychiatric care at Guantanamo Bay. And this is a case where if you look at this story, you would have no idea that a software engineer or any kind of data component may have been involved because there's no graphic, there's nothing that looks like data to you. But the data component was really important in the reporting. It's how we found the source and it's how we told the story. Yeah. So I'm going to tell you another story. This is a story about data that is too big for a reporter. Once upon a time, the data just kept coming and coming. This is a lot of data. If you fiddle around with data a lot, you might be familiar with XML. Here is some. Can anyone tell what this is? Can you guys see it well enough to tell what this is data of? Oh, we've got it over there. It's the Olympics. This is what the Olympics looks like on the back end. During busy competitions, we can get 20 messages a second from the Olympic data stream. And yeah, so it's a large data set. Thankfully, in this case, no one passes go. No one collects $200 before they call the nerds. Huge amounts of the Times Olympic coverage is powered by 2 news nerds sitting in a press tent in the Olympic City. My colleagues Michael Strickland and Scott Blumenthal were there in Rio. They gave me a little rundown of how that went. Our team keeps, and in fact, our team keeps a collection of Olympic mascots, the little dolls, because the Olympics are such a huge part of the data work that we do. So what do? We power graphics. We get reporters the most accurate information and times, and we answer questions. So if you enjoy watching the New York Times cover the Olympics, if you enjoy things like split times, if you want to see those races that get run in real time and things like that, that's all thanks to this data stream. In fact, my colleague Michael just spent a week, like 2 weeks ago, in South Korea, starting to prepare for next year's Winter Olympics. The news nerds from around the world whose organizations cover the Olympic feeds are actually required to participate in massive testing exercises as part of their data contract with the games that start nearly a year in advance. So yes, if you enjoy watching this kind of coverage, thank a news nerd. Anyway, this is actually one of my favorite stories from Rio. I know it's not as exciting as Katie Ledecky winning by 97 seconds or whatever it was, but what I like about this is that it's a narrative story that came out of the data. So one of the reasons this story came about is because my colleague Scott Blumenthal, who is a software engineer, is also a huge boxing enthusiast and boxes himself. So he had his eye on boxing from the beginning, and he was talking to the reporter who was working on it, and they noticed that there was some scandal about competitors who were worried that judges were biased, and they wanted to take a little bit of a look at that. They wanted to know, like, what are we seeing or whatever. And when they started looking, they realized that there were some judges who just disappeared from competition because judges are in that data set, the judge of every match. There were judges who judged at the beginning and then stopped judging, and there was no clear reason. They weren't like, their ratings weren't bad or whatever. They just disappeared. And so they were able to use the data to find the story that the judges were just gone. They were dismissed, but it was secret. Let me tell you. There we go. Let me tell you another story. Once upon a time, the open government data was in an adversarial format. Uh-oh, heard some laughing there. As you may be aware, we had a major event in Washington this January. It was a presidential inauguration. Unfortunately, after every party comes the bill, the cost of a presidential inauguration is covered by fundraising from the Presidential Inaugural Committee, and they have to release a list of donors to the Federal Election Commission. Here's what it looked like. What they did is they took this report and they delivered it on paper to the Federal Elections Commission. Someone knocked on the door of 990 East Street and or 999, I think it is, and handed it to the Federal Elections Commission. I just want to point out that this was not how they had to release it. It's not in statute that they have to release it in paper. The last two of them released them online. And it's not like they typed this out on a typewriter and that was the only way they could do it. This is software. They just chose to hit the print button instead of hitting the send to FEC button. Yes, so it was not machine readable data. So basically, the very next call was, find me a nerd. Unfortunately, the sad story here is that the news nerds aren't actually that much help in this situation. The data is pretty badly locked up, and we knew it. But what did we do? We combined our nerd powers. This is a repository from an editor at the Washington Post named Stephen Rich. He started manually cleaning this filing in public. Pretty quickly, he had collaborations from reporters or from news nerds of various sorts at a variety of organizations. I'm up there, you can see, and a few other folks. So in the end, we had five different organizations contributing to this kind of information. Another fun fact about this day is that I saw that this filing was out as I was eating my breakfast, and the next thing I remember, it was 4 in the afternoon, and I was sitting on my sofa in my pajamas, still manually entering these things. So it was a long day. Despite the collaboration, the news organizations wrote their own stories. It's not like we wrote one story, but the background data was in some ways collaboratively managed. The saddest news in some ways for the news nerds is that by doing all of this work, we helped reporters discover that there were some issues with the filing and just a few errors in the way it was filed. So that means they had to file an amended report. What did that mean? Another one of those paper filings came out about 3 months later that we all had to dig into again. They didn't file that one electronically either, as you could probably guess. So let me tell you another story. Once upon a time, the structured data was hiding. Perhaps you heard of this guy. He's like kind of famous, I guess, these days, especially maybe in this kind of a location. He wrote a play about some guy named Hamilton. Apparently people really liked it. They liked it so much that they bought that tickets are now going for thousands of dollars. I just want to point out that on this thing, it looks like it says 2 tickets because that's the smallest number you can buy. But this is actually the price for 1 ticket. They would double it if I bought 2 of them. So this is how you buy a ticket for Hamilton, I guess, these days. One of the major problems, one of the reasons that the tickets are so expensive is the resale market. And people in New York, understandably, and at the New York Times, were really interested in how this market was working and what was happening, and how resale companies were using bots to buy up these tickets and then sell them again. So they thought, if only we could monitor how dates are selling out and what the costs are. I bet you'll never guess what's coming next. Yes, they called in the nerds. In this case, it was my colleague Tiff Furr. And she basically wrote a ticket buying bot, but instead of buying tickets, all it did was look at the prices and whether things were sold out. So it turns out a lot of people at the Times were interested in this data, potentially given our proximity to Broadway there. So by recording this ephemeral data, Tiff was able to put together a full structured data set that helped reporters understand the scale of scalping on Broadway for a variety of stories they were telling. So this is what they think Hamilton scalpers are making in these ticket sales. So how am I doing on time? 5 minutes. OK, I'm going to add one more story that I don't have slides for because it's particularly relevant today. So one recent situation where we really wanted to get some data was that the House of Representatives, our neighbors right across the street, were voting on a healthcare bill. That's going to happen again today. The Senate gets to vote. Unfortunately, it's quite hard to get the data out of the House and Senate quickly because a lot of it is being recorded by hand by the clerk of the chamber. So what we ended up doing in the House, and what we will probably end up doing in the Senate this afternoon, I apologize if I have to leave early to do this, is have people actually sitting in the chamber and quickly writing by hand and doing things like run out, take a photograph, send it to someone in New York who's going to transcribe it, and run back in. We are literally manually entering data and sending it back and transcribing it and making it electronic that way. In some cases, that's the fastest way to do it. And it works very well for us in getting House votes live. Some people have said, why do you need to do that? The data is going to be available in 40 minutes maybe. One thing that you can't get from that data, especially in the House, is when people change their votes, which is actually a pretty common strategy in the House. Sometimes it's accidental. The way you vote in the House, I learned a lot about how you vote in order to do this in our bodies of representation. In the House, what you do is you slide a little card into a machine, and then you hit, I guess there's a big yes and no button, and you hit the button. So people just hit the wrong button. There was a little scandal a little while ago about people letting their kids vote for them, which I think was causing a few more of these errors. But so that's how they do it. If they vote incorrectly, they can go and change their vote back. And there's some thought that people might vote strategically. They might say no, or they might say yes. And then if they're not really needed in the final count, they might change. So by recording the votes in real time, we were able to get that information out. It was hard to do. We needed 5 people in the chamber to do the House. Thankfully, the Senate's a little smaller. We're hoping to be able to get by with a few fewer people. So like every good story, I'm going to end with a happily ever after. Just the New York Times, we have more programmers in the newsroom than any other news organization. And we do graphics and digital storytelling. And we do creative news presentation. But we also work with data for nearly every definition of the word data. So yeah, I'm ending this the way good stories all end, with a happily ever after, with some very small exceptions. So thanks to my colleagues who walked me through some of the work that they did on data stories so that I could share a more wider perspective. And yeah, that's all I got.
This has been a presentation of the Library of Congress. Visit us at loc.gov.